Okay, so welcome. This is a continuation of my series of videos slash live streams in which no one comes live, but that's okay. I'm just recording them. And I'm implementing a parasitic C compiler, and by parasitic, I mean it is a C compiler written in C that generates C code as its target language. So the source language, the implementation language, and the target language are all C. And we're doing this so that it is easily bootstrappable. As soon as it's working, it can compile itself. Or really, I'm implementing a compiler for a subset of C. Hopefully, like the smallest subset of C that you can write a compiler in, because I want to keep it as simple as possible. And the um, once we have the compiler bootstrapped, then I can start changing the language that the target language, or no, the source language, so that it becomes its own language. It's no longer C. I can start adding features and stuff. So that's the goal of the project. Um, in this stream, let me set a timer really quickly. I'd like to keep it around 45 minutes. Okay, we've got a timer going. In this stream, we're going to continue working on the parser. We're making a recursive descent parser, and where we left off, I was having some problems. I was having some bugs where uh, um, essentially the current token that had just been parsed was not being recognized. So I figured out how to solve that. Essentially, in the Lexer, I had been over in the parser. So we're parsing a literal int in this function. We're asking the Lexer to, ensure that the next token is a literal int token, and then we have access to this global variable called token, which points to like the string slice, or it's an allocated string representing the token that was just parsed. So this should be the text of the int that we just tokenized. And we call a to y to turn it into an integer, and we store it in the AST. The problem that I was running into was that Lexer accept, if I go to the definition of this, checks that the tag is the expected tag, and then calls Lexer advance. So after this function exits, inside of this if statement, token points to the next token, or potentially, sometimes it's not set. If the next token were a keyword, it would not be set. So this is actually kind of a nasty bug that I'm glad I caught now. So the solution to that is to have another global variable called next token. I named it Lexer next token. And in Lexer advance, we just save we sort of shift these over. So this is like current token, this is next token. We shift these over before performing the lexing step. That way, when it's advanced, we still keep track of the previous one. So essentially, I believe this is an LL1 parser, because we have like a one. The one stands for like one look ahead token. And I believe that's what's going on here. So I should have access to the next token at all times. I don't know, that just happened. So so that solved the bug. If I recompile and run, yeah, it does print out -1234, which is our test example down here, -1234. So that's good. I was thinking about it, and I believe we're also going to run into the exact same problem with token tag. So I think we also need like token tag equals the global variable equals lexer next toke tag, like this, and then we will be passing in lexer next token tag, in case we need to inspect this current token tag. And I was in the Wikipedia article with the code that I'm basing this off of. Their equivalent of token tag is the global variable sim, and they are doing direct comparisons on that. So we're definitely going to need access to the current token tag, not the next token tag. So let's go up to the top to where our globals are defined. Token tag, and we're going to say lexer next token tag. Next. And can I close that? Yes. Okay. And then, so I believe that should be working. Token tag is now the current token tag. Token is now the current token. And this one is the next one after we call advance. Okay. So at this point, I was also thinking, you know what? Instead of having these global variables, why don't we just make a struct? Yes, we'll have to pass around the, the lexer's state. This is going to be a struct lexer, and we'll just throw all of these in here. So I am going to have to type out struct lexer, which is a little annoying, but whatever. And then I can get rid of these like lexer prefixes, which is, that's nice. Yeah. Okay, so now we have a lexer struct. And I guess it makes sense to move this down to where all of our functions are. So lexer advanced, this is right below the lex function. Let's add a divider here. Okay, and then lexer advance now takes a struct lexer pointer called, I'm not going to call lex, or I want to keep it short. I'm not going to call it L because that's not very readable. I'm going to call it LXR for lexer. And then we need to say LXR token equals LXR next token. LXR token tag equals next token tag. And LXR input a reference to LXR next token tag, LXR, and LXR input. LXR. Okay. And then here, I actually don't need this function. That's not really necessary. We're just going to have lexer init. So this is going to be LXR input equals new input, the one we pass in, and we're going to call lexer advance on LXR. Oh, and we need to create the lexer and return it. Okay. So we're going to return a struct lexer. struct lexer lxr. And I suppose I should initialize all the fields. I've also decided I don't want to do struct initializer syntax because that's just another syntactic form I'd have to deal with. So I'd rather just do dot notation. Oh, right. And since this is not a pointer, we don't need that. Return LXR. But I do want to think about which fields I need to initialize in the init step. That will get initialized. Token tag, that will get initialized. I believe these all get 0 initialized. Isn't that the case? Let's look it up. In C0 initialization struct. Initializing a struct to 0. First is easiest and is guaranteed to work. All members will be set to 0. Second is more readable. If there are fewer initializers in a brace enclosed list than there are elements or members of an aggregate, or fewer characters in string literal used to initialize an array of known size, blah, 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 the remainder of the aggregate shall be initialized implicitly the same as objects that have static storage duration. So this mem set 0. They're suggesting this. All right, well, why don't I just set the fields? I do need to kind of think about how this is going to work. Okay, so lexr_init. Let's just take each of these fields, token tag, lxr.token tag, set it to -1, lxr.next token tag equals -1, lxr.token and next token equals null. We know we can do that. lxr. Next token equals null. And input is the last one. So what I'm concerned about is that we call lexr advance here. And at that point, I want to check what token tag and token get set to. So if we call lexr advance at this point, token gets set to next token, which is null. Token tag gets set to next token tag, which is -1. Fine. So these are still kind of garbage values. And then next token tag and next token get set to the first values. Okay. I think that's okay. We'll have to think about it a little bit. Okay. Lexer accept. So this needs to accept a struct lexer pointer LXR, and we need to say advance with the LXR. Yes. And this needs to accept the exact same thing. Yank and paste and LXR. Okay. So now all of our parsing functions. I was also thinking about this. We want to accept a lexer. Struct lexer pointer LXR. And we want to return we can just return the pointer to the object, the AST object. So instead of all this, we can say struct expr pointer expr, and that simplifies this code a little bit too, which is nice. And here, instead of token, it's going to be LXR token. Instead of lexer accept, it's going to be LXR. We have to pass that parameter in. And then finally, we return expr, which is a pointer. So that's cheap. And then I guess out here, we should return null. All right, so how would we use this now? We would say reference to LXR, struct lexer LXR equals lexer init on this. Oops, extra semicolon. Okay, let's try running it. Whoa. Wait, what? Okay, compilation errors. Expected a semicolon at the end of declaration list. Where are we? Let's go here. Oh, right. Yeah, you can't have initial values in a struct. What's going on here? Yes, I need to pass a reference in order to advance. Here, struct lexer. Passing argument. Oh, right, that's just help for this. Use of undeclared identifier token tag. Yes, so this is LXR arrow token tag. Okay. Let's see if that fixes everything. Some kind of big problem. Let's try running the compiler with W extra. W error, W all. Alright, it's just complaining about these things. And this down here. The value, the variable new input is never used. Yeah, but I do need it, do I not? Oh, maybe not. Dash W pedantic. No new line at the end of the file. Okay. This really is pedantic. Okay, so Clang is not being helpful at all. But we might as well keep those warnings there. All right. So just to test, we are testing the new parsing method. That's in our main. We're creating a lexer struct with lexer init. We are parsing an expression, a literal int new. Yeah, parse the expression literal int with a new method. Pass in the lexer. Pass in the lexer. We return a pointer to an expression. Return a pointer to an expression. And then we display the expression. So it might be a good idea to, if expr equals null, printf null expr. Let's see if that's a problem. Are we getting null for some reason? Yes, we are. Okay. So somehow we are not accepting a literal int token. Okay. Somehow this is returning false. Lexer accept. Lexer advance. Token tag. I think this might be the next token. Does it work now? Yes. Okay. This is frustrating because I thought I understood what was going on, and now I don't. So maybe we don't need next token tag. I don't understand why like token is being updated. Okay, maybe just internally we just need next token tag here. Maybe that's the only place we need it. And then over here, let's check what not next token tag, but token tag is. So let's go in here after the call to Lexer accept, and let's just print token tag equals %s, new line, token tag names of Lexer arrow token tag. So what is the current token tag at this point? My theory is that it's the correct value at this point. Literal int, yes. Okay. So we have to do next token tag here because this is before we call advance. And when we call advance, these things get shifted over. Okay. And then since we call accept before we look at the internal state, by the time we look at the internal state in here, where we want to look at the internal state, like token tag and token, then we're all set up. Okay. So let's add like a note here, because note, we check against next token tag, not token tag, because in order to set up took tag for calling code after Lexer advance is called here. All right, that's not a great note, but it's close enough. Okay, this is a really good start. I feel like we have everything we need to begin doing the parsing. Okay, so I'm going to commit this, reformat, refactor lexing and parsing methods to align with recursive descent parser approach. I'm really bad at writing git commit messages. Okay, and we'll sync those changes. Okay, but this is really good because we're now in a position where we can get rid of, in fact, maybe I should just like delete, I don't know, like all of this parsing stuff. No, let's replace it one by one. Okay, parse expression literal int. Parse expression literal int new. Yes, so we want to get rid of this one because we've replaced it. I'd like to get rid of this. All right. And we're going to now rename this to that. Parse expression literal int. Paste that there. We do not need the input. All we need is struct lexer pointer lxr. We don't need these. We don't need this. To parse a literal character, what we need to do is we need to say if lexer accepts the lexer token literal char, then we're going to do all this. We're going to say struct expr pointer equals malloc. We don't need these stars. LXR arrow token and return expr. Otherwise, return null. Is that it? I think so. Here, we need struct lexer pointer LXR. We don't need these. We need to say if lexer accept LXR, comma, this, return null, and auto format, struct expr pointer. We need to get rid of one of these stars. At this point, it's just repetitive. Return expr. Okay. Same thing here, literal bool. This one's going to be a little bit trickier. Struct expr pointer. Struct lexer pointer LXR. Okay. So at this point, I believe we need to manually call lexer advance on LXR. And then we have access to LXR token tag, LXR token tag. Whoa. And we don't need these extra parentheses. So if the token tag is true or false, then we're going to say struct expr pointer. The tag is expression literal bool. If LXR token tag equals token true, then we're going to do this. Otherwise, it's false, so we're going to do this. And at the end, return expr. Otherwise, return null. Okay. I would like to test this one, because I'm concerned that it's not going to work. So we should have like a whole bunch of errors down here. Struct lexer LXR equals well, I guess we need to like sort of init this in each case. So we want to say LXR equals lexer init -531. Parse literal int. We just need to pass in the new lexer. And we can say expr equals. Oh, and this should be by reference. And if this is non-null, then we can display it. Otherwise, we need to say test failed. Okay. Okay, this is going to be a character literal. And I should be able to add spaces around these if I need. Yeah.
Yeah, I'm just coming in.
Hey, hey, kitty.
She was playing with the string thing a bunch.
The string toy.
She kind of chewed it up.
Oh wow.
Paper's ripped a little bit.
Okay. Literal char.
So where are we today?
Still working on the parser. But making progress. I learned a lot from reading a Wikipedia article. So I did some research and implementation there, which was cool. This should be \quote, \quote.
I was like, wow, he probably went so fast it looks
No.
like just scrambling letters.
Yeah, I'm just putting garbage stuff in here. String. And then Boolean. Okay. LXR equals lexer init with true. And this is going to be, yes, bool ref LXR expr equals. And this should be false. Okay. I'm going to comment out all of this stuff because that is not going to work right now. And all of this stuff as well. And then we're going to say test the parser. All right, we've got a lot of errors. Unused variables. Okay, comment these out. I hope it's not going to complain about unused functions. That would be annoying. Using the result of an assignment as a condition without parentheses. Okay. Doesn't like this. Yes, very, very safe of us to put an extra set of parentheses. Test failed, no error. Okay, so let's see. What exactly happened? First we tested this number, and that worked. Next, we tried to test this character literal, and it failed. Next, we tried to test the string literal, and it succeeded, and then true and false both worked. So the character literal did not work for some reason. Let's see why. Um, because this says string instead of literal char. Okay, yeah, so that's working. Let me see how much time I have left on here. 7 minutes. I think this is a good stopping point. I might go back and re-implement all of these other items and that we have to do some maintenance on. And then in the next video, maybe I'll start off with some more interesting constructs and talking about the grammar a little bit more. So maybe we'll, at the beginning of the next video, we'll be working on parsing while statements or something like that, something more interesting than like literals. Okay.